Hey guys, in this video we're looking at tree diagrams and two-way tables. Tree diagrams, you would be familiar with something that looks like a branch, and it just kind of expands, whether it's going from left to right or from top to bottom. But similar concept to that. And then two-way tables, you would have event A over here, you would have event B over here, and you would have a grid to kind of show what they have in common. It's a really good way of displaying your sample space, displaying the outcomes of multiple events happening, and yeah, so wanting to let's say we flip a coin, because I've got a couple examples coming up. So we've got a coin, and so we've got tails and heads. Okay, and then if you flip the coin again, I guess you can have either another tail, or then you could have a head, tail, and then head, obviously, and then you got tail, head, tail, head, tail, head, tail, head. So this is in the circumstance that you were to flip the coin 3 times. Okay, so if you flip the coin 3 times, you could essentially have 3 tails in a row. Okay, and then if you could also have 3 heads in a row. Okay, or you could follow the path where there's 2 tails and a head, or perhaps you might have a head, then the second time you flip is a tail, and then the third time you have another head. So head, tail, head could be another outcome. Obviously, we've got 1, 2, 3, 4, 5, 6, 7, 8 outcomes here. And in this case with event A and event B, this case with, let's say we're flipping a coin 2 times. Let me write this down. If we had to flip the coin 2 times, you could have 2 tails, you could have 2 heads, you could have a tail and then a head, and you could have a head and then a tail. And in this case, you have 4 outcomes. All right. So let's have a look at this example here. And this one is just looking at two-way tables. All right. And in this case, we've got a coin that is tossed, and then a spinner on the right that we have that is kind of twirled or spun. And so if we say a coin, then obviously there's only 2 outcomes. We've got a head and we've got a tail. All right. But then if we're looking at the spinner, we have 3 outcomes. We have a 1, we have a 2, and a 3. Now it doesn't really matter. I know it's color coded, so you could have purple, red, and then green. In this case, I'm just going to use colors, numbers. And if we create the grid together, outcomes, in short, is going to be okay, the number of outcomes in event A multiplied by the number of outcomes in event B. Okay, so I might just detail this so I'm not taking any shortcuts. So the number of outcomes in event A, okay, the coin in this case, is 2. And the number of outcomes that we have in event B, which is the spinner, is 3. So if you ever want a quick way to calculate the total number of outcomes possible, you multiply those 2 totals, which is 6. Okay. So what we have here, we could have a head and we could spin a 1. Okay. We could have a head and we could spin a 2. We could have a head, we could spin a 3. And in turn, we can flip a tail and spin a 1. We could flip a tail and spin a 2. We could flip a tail and spin a 3. So they are our outcomes. Okay, we got 6 of them there. So question B says, what are the chances, what's the probability of obtaining a head and a 1? And if you look at the 6 outcomes, there's only one of them that actually has that. And remember, we want both. And your comprehension and your, I guess, awareness of the words that they choose is really important. So head and 1 is just going to be 1/6. Okay. Part 2, we want tails and a 2. So tails and a 2, it only happens once as well out of the 6 outcomes. Tails and a 3, that only happens 1 out of 6. Heads and a 2 is also 1 in 6 chance. Okay. 5 says tails and an odd number. Okay. So tails and a 1 meets that description, and tails and a 3 also meets that description. So in this case here, it's 2 out of the 6, which is a third of the possibilities. Okay, so hopefully that helps you with two-way tables. Now let's look at the tree diagrams. So again, we're not looking for anything different. It's the same thing, but just in a different format. Okay, so here we have a bag that contains 2 red balls and 1 black. A ball is drawn or taken out, and it's colored noted, and then it is replaced. Okay, a second is drawn and then made. Use a tree diagram to list all the possible outcomes. Place each red ball on a separate branch. Okay, so remember we got 2 red balls and 1 black, and then find the probability of drawing a black. We got a few outcomes here. Okay, so let's look at this. So you could have a red, and then you could have a black. Okay, or what we could do is this, because they want this. So you could start off with a red, and then what you could do is you could then have, once you've replaced it, you still have 3 outcomes. You can have another red, you can have another red, you can have another black. You could do the same thing. You could have another red, and then you could have another black. And if you take a black, obviously when you put it back in again, you're going to have the same thing, a red, and a black as your options. So only a second draw, there's nothing more than that. So that means, remember, we multiply the 2 total outcomes. So the event is 3. So event 1 is 3, and because we're going to take take a second ball out, we also have another 3 chances. So 3 times 3, we're going to have 9 total possible outcomes. Okay, so the first one, we're going to have 2 reds. The second one, we also have 2 reds. The third one, we have a red and then we have a black. The fourth one, we have 2 reds. Fifth one, 2 reds. Sixth one, we have a red and then a black. Then we have a black and then a red. Then we have another black and then a red. Let me tidy that up. And then the last possible outcome, selecting 2 blacks. Okay, so find the probability of drawing a black and then a black. Okay, and then if we look at the outcomes, there's only one of them that meets that description. So 1 out of the 9. I'm not going to do every single one of them, so I'm just going to choose them random. So in this case here, we got black and then red. So this keyword then states that the order is important. Okay, you have to start with black and then finish with red. So we're going to start with black, finish with red. We have 2 of them. So in this case, we have 2 out of 9 that meets that description. If we look at 7, which says no reds, okay, that means it's just anything that is only with black. That's only just one scenario, okay. And then if we have neither red nor black, well, obviously there's nothing that fits that case. 0. There's no outcome that meets that description. Now, if we have something like finishing off with this last one here, number 11, at least one black. So if we're saying at least one black, we've got these options here. This one has a black. Oops. How about we highlight it? The thing that has at least the one black is that one, that one, that one, that one, and that one. Okay, there's 4 of them, is just 2 reds, and the others at least have 1 black. In this case, it's only, we count them all up, so 5 out of the 9 possible outcomes meet that description. Alright, so hopefully that helps you guys for two-way tables and tree diagrams. If you got any questions, let me know. Otherwise, I'll see you in the next one.